Okay, we're going to take a look at our example around Morse and the picking apples at the orchard. So we need to have a look at the equation initially, and we need to understand basically what's going on with the equation and what it's telling us. So we basically need to understand that this equation is giving us information about where the graph crosses the x-axis, okay? So this graph is you can put it into your graphing calculator and basically, but what you need to see without putting it into the calculator is this is factor form. Whenever you have an equation in this form, this is factor form. This is a factor and this is a factor. So that is telling you where the graph is crossing the x-axis. All right. It's telling you that it's crossing the x-axis at 0 and 16. You need to know that. You need to know that if you're going to get to excellence without actually having to put this in your calculator. You know it's negative, so you also know that basically the graph is going to look like this. Okay? So having done that, you know some things. And in order to answer these questions over here, you're going to need to be able to use your calculator, get this into your calculator without too much trouble and so on. So we go to our calculator and we put in the equation properly and we ask it to draw. Now the problem is that when we draw this particular equation, it doesn't show up very well. I mean, it shows up a little bit, but you might have some serious issues. There's a nice little bit of magic with zoom on a calculator. If you go Shift F2, you get into a zoom function. If you go to auto, you will see that, and then I can scroll over and I can get that graph to sort of show. I can do it again, zoom, auto, and I can get it even better. So I need to have this graph showing me my vertex and so on, and also need to have it show me where it's crossing the x-axis and things like that. So I could do my G-solve and I could get my roots, which is at 16, and if I ask it to do it again, now that's going all the way over. G-solve, root. Okay, exit, draw, and if I go over and get the other one, then I can go G-solve, because it'll only G-solve the roots that it can see. So you might want to zoom it out some more, I don't know. But anyway, you get the idea. So when we do this, we get our roots, and we already know that what the graph kind of looks like, or we should know what the graph looks like. Now, can we get the vertex? Because that's always an important thing to get. G-solve, and it's a maximum point, 8 and 0.64. So this point here, which makes sense because it's halfway, is 8 and 0.64. So we get a vertex. And we've got x-intercepts. Now let's see if we can answer some of these questions. So we've got Moore's picking apples, picking apples, picking apples. He maxes out so this is weight, right? So this is my weight on the y-axis, and this is days. So it's important that you understand that. So we've got a pretty good sketch of this graph. And then he's picking apples. He maxes out the amount of weight and the amount of apples, and then the apples starts sort of falling off because he's picking all the apples. And so can we answer this question? How many days does he pick apples? Well, he picks apples for 16 days because he starts here and he goes all the way over to 16 days. On which day did he pick the most apples? Well, on the 8th day he's picked the most apples because that's where the maximum point is. What was the weight? Well, it's 0.64 tons because that's what the point of the vertex is. On which day did he pick 0.55 tons? Now there's a couple of ways to get this answer. 0.55 tons is a Y value, right? So let's just say if I go to my menu and I go to table and I look at my table and I want to get some values, so I'm going to select it, table. Now, what happens if my table doesn't go far enough? Oh, 5 is 0.55. So on day 5, it's 0.55. Right here, day 5, 0.55. But with a quadratic, you've got symmetry. So it's not just day 5. It's not going to be just day 5 when it's 0.55. There's another day over here where it's going to also be 0.55, right? How do I find that day? Well, I could go to my table again, but I would need to expand this table set. So I'm going to have to set it up so it goes further than 5. Let's say it goes to 16, because I know that sort of finishes off my graph. And go to the table. And there's my 5 and 0.55. Let's keep going. 11 and 0.55. So if we go back to my graph, this is 11. So when the graph is 5 and 0.55, that's tons. It's also, there's another day when it gets to that point because of the symmetry of a graph. So at day 5 and day 11, you need both of those days.